There's another category of attacks on WEP having to do with isolated clients. They go by exotic names like Cafe Latte and Hirte. But what do we mean by attacks on isolated clients? So far, we have been looking at cases where we have an access point that is using WEP encryption, and then we try to focus our attack on that access point. We have seen, for example, the use of passive attacks with PTW, Correct FMS, where we just listen to traffic to and from the access point, and also active attacks where we go inject frames into the Wi-Fi network. So far, therefore, we have always been having an access point and some clients around it. Well, what happens if we don't have an access point that's easily accessible? Maybe, for example, the access point could be in a secure location and you cannot get close enough. Are we then unable to do anything about it? One point to realize is that when we use WEP, not only the access point has the WEP key, it's a shared secret. Therefore, all the clients also have the same WEP key. This is important because now we can think about how we can recover the WEP key even if we don't have the access point around and it's just a client. The idea is to try to get the client to generate frames with different IVs even though the access point is not around. How can we do that? The first such attack that we'll talk about is the Cafe Latte attack. Before the Cafe Latte attack was introduced, there were already ways that people could do this kind of thing using tricks like forcing the client to deauthenticate, but it would take a very long time because the client would have to reauthenticate, and so it was not very practical. The Cafe Latte attack, in fact, goes by that name because it was something that could be done relatively quickly. Supposedly, the amount of time it took you to have a cup of cafe latte would be similar to the amount of time it would take for you to be able to get the WEP key with this attack. The idea is to do ARP replays. So we have already seen ARP request replays in earlier videos. In this case, though, this is without the presence of an access point. So we would naturally ask that how do we make a valid ARP request when we don't have the access point and we don't have the WEP key? We need to replace something that is going out over the air. The problem is that the isolated client, even though it has a WEP key, it cannot associate with the access point since the access point is not there. It therefore cannot send ARP frames. It needs to be part of that Wi-Fi network before it starts sending the ARP frames. So you cannot rely on the isolated client to help you with ARP requests. Therefore, one of the key features of the Cafe Latte attack is that we set up a fake access point with the same ESS ID as the original access point. The beauty of this is that, well, beauty of it, depending on your point of view, if you're thinking about WEP and how horrid it is that it has all these errors and in design and problems and vulnerabilities, maybe you don't think of it as the beauty. But anyway, I'm saying that there's no server-side authentication, so the clients do not authenticate the server. So you can set up a fake access point and just claim to have that ESS ID, and the client will try to associate it with it. So the client will try to associate, you just tell it that it's successful, and then upon association, the client will send gratuitous ARP requests with its MAC and IP address. This is its normal behavior when it joins a LAN, so that others will know whenever there's an IP packet that is addressed to its IP address, the other members of the LAN will know which MAC address to send it to. So this gratuitous ARP is so called because it's sent not in response to an ARP request, but let the other members of the LAN know. So it's gratuitous in that sense. And how do we generate the ARP request then to get the ARP responses? Because now this client is sending this gratuitous ARP. What can we as the attacker do? We can capture a gratuitous ARP, which happens after association with the fake access point. And there's a few bits that can be flipped to transform it into a genuine ARP request. So it's no longer a gratuitous ARP request, but a normal ARP request. And then this can be sent, because now let's say we just have this one or a few gratuitous ARP requests. We can generate a few genuine ARP requests. That's not going to be enough. We need to get many more IVs, but we can by sending out this ARP request many times. We'll be getting ARP responses from the other clients. Well, in this case, let's say we just have one isolated client. So our attacker could be generating this ARP request from that network card that's faking as an access point. And this isolated client would then be generating ARP responses in response to the ARP requests. The ICV, as mentioned, is easy to modify too. So there's no way that the client will know that this is not a genuine ARP request, and it will respond with ARP responses. And once we gather enough of them, we can crack the WEP key. The Herte attack is similar to the Cafe Latte attack, except for a couple of differences as mentioned below. You can use any IP packet, not just gratuitous ARP requests. There's a more complicated process of transformation, and it involves the use of fragmentation as well.